Yes, sir. Hey. What's up, brother? Oh. Hey, what's up? How you doing? How you doing? Hey, what's up? Hello, I'm President Barack Obama. And we are now doing ObaMATH. Brought to you by yaymath.org. Yeah, give it up.
Let's go, yaymath!
Yay! Yay!
Matt.
Yay!
Hey.
Yeah.
So we're burning the midnight oil here in the Oval Office. We're almost out of here, so before we go, I'd like to do a little trigonometric functions. And I practiced how to say that very quickly. Trigonometric. Circular function goes as follows. Check it out. Please draw your axis and triangle. Let's make it a 3 and 4. What is the hypotenuse, sir?
5.
5.
5.
How would you be able to verify that? Using which theorem? Say it.
Pythagorean.
Pythagorean theorem. If you did 3 squared plus 4 squared equals c squared, you'd be able to get c equals 5. All right? But the 3, 4, 5 happens very common. All right? Super common. Let's go ahead and get the sine and cosine. All right? Here's our angle. Sine of theta equals what over what? All right, let's put it down. So much love in the
I
world.
didn't hear the question. I was writing this down.
All right, you're good. You're good. Sine of theta equals what over what?
4 over 3.
Almost.
Sine?
Man.
Sine?
Yeah.
4 over 5.
4 over 5. Opposite over hypotenuse. 4 over 5. Cool.
I was looking at Toa.
Okay. And now let's do cosine.
Beta.
Equals adjacent over hypotenuse.
3 over
equals
5.
3 over 5.
They said they were never going to erase it.
I know. I get in the zone and I start to race and stuff. You know? Okay, now I want to show you something very interesting about what we mean by unit circle. Do you agree that any right triangle would still be a right triangle if I multiplied each of these sides by the same number?
Yeah.
I could do that, right?
Yeah.
I could scale it up times 2, times 5, times 10.
Yeah.
Would that also mean that I can divide by the same number?
Yeah.
What I want to do is I want to make this hypotenuse 1. If I wanted to make this hypotenuse 1, I divide everything by 5. And if I did that, the triangle would look like this. All right, if everything divided by 5. So let's actually put that in. Divide by 5. All right, now what would the hypotenuse be?
1.
1. What would this be? Fraction, what over what?
4 over 5.
That's right, 4 over 5, that's it.
3 over
And
5.
this is 3 over 5, very good. And what would this point be, put in blue?
Wait, divided by 5?
Yeah, if I divided by 5, because I want the hypotenuse 1, I'll tell you why in a second. What would the point be? X comma y?
3 over 5.
Comma?
4
over 5.
Does that make sense to you?
Yeah.
We're graphing the point positive 3 over 5, 4 over 5. Put it down, 3 over 5, 4 over 5. Now, look closely, okay? 3 over 5 we've done before. 4 over 5 we've done before. Where does the 3 over 5 come from? What else was it?
Wait, is this a right triangle?
Yes, it is a right triangle
Boxy.
with a hypotenuse of 1. 3 over 5 was derived by which trig function? Look closely right there.
Cosine.
Cosine of what?
Theta.
Yeah, theta, that's right. Theta, that's right. It takes a while to say it. Try it again, theta.
Theta. Oh,
There.
theta. I thought you said
Theta.
I'm like, oh,
Yeah. It's
Theta.
spelled theta, but it's sort of spelled like feta, but
Yeah.
theta.
theta.
And then 4 over 5 comes from what?
Sine.
Of what?
Theta.
Yes. Okay. Now, I'm going to spell it out for you very, very deliberately, very clearly. Okay? If the hypotenuse is 1, if the hypotenuse is ever 1, this point is always cosine of this angle, comma, sine of this angle. Again, write it down.
What?
If hypotenuse equals 1, the point created, we'll do this again and again, and then we'll finish. The point created is cosine of the angle, sine of the angle.
Yes.
All right, let's try with a different triangle, okay? Right, go! All right, let's erase these. And erase these. All right, and this. I'd like to do a 30-degree triangle right here. So this is 30. This comes off, this comes off. All this goes. It's like a art form. It's like an art form. It's like my visual palette here. Setting this up.
You want to be an art?
Yeah, now I'll be an art teacher. Yeah, I'm done with the trig. I'm done. I'm done.
Oh my god.
No security. We're okay. No, go back. Okay. So 30. Here's 60. Now a traditional 30, 60, 90. Where does the 1 go? Across from?
Across from a 30.
That's right. Where does the root 3 go?
Bottom.
Very good. And where does the 2 go?
Hypotenuse.
Very good. Let's go ahead and get sine of 30
Okay.
and the cosine of 30, shall we?
Wait, Mr. President, what if
Yes,
we
sir.
put the triangle in the second quadrant?
We can do that. Yeah, we're gonna.
Would that mess things up?
It would create negatives.
Right.
Yeah, we'll create negatives.
Okay.
Let's do that. No, it's not. It's just the flip flop of the flip flop and flop flip, which I'm gonna wear in Hawaii. You flip flops. So sine of 30, hook it up, is
Half.
yes, 1/2. Cosine of 30 is what over what?
Root 3/2.
Very good. Now let's create a hypotenuse of what? What do we want the hypotenuse to be?
1.
By dividing that entire triangle by the number? 2. Very good.
Brought to you by the number 2.
Sesame Street stuff. Okay, so if we divide the entire triangle by 2, what would the new hypotenuse be? It would be 1.
And then 1/2, and then
And then 1/2.
and then rad 3/2.
And then rad 3/2.
Which is exactly that.
Which is this cosine of 30?
Yes.
Cosine of 30 is?
Through
Root
rad
3/2.
3/2.
Yeah. Which is the x value, see it?
See it, believe it.
And is this sine of 30?
Yes.
Which is?
1/2.
Yeah.
Which is the y value,
Total height.
1/2. Does that make sense?
Yes.
Okay, so what we're gonna do now is we're going to fill in the unit circle at all major angles. I'll show you how it works. It's really not so bad, okay? It's really not so bad. I'll show you how it works. So we're gonna do a very big one now, okay? Really big. So we have already the 30-degree one. Let's draw the 30-degree one. Go like this. If this is all, like the hypotenuse is always 1, what was the point here? What comma what? Was it a 1/2? Root 3/2. Oh, it was root 3/2 comma 1/2?
1/2.
Okay. Root 3/2 comma 1/2. Okay, now remember that was 30. Let's do your question about going into quadrant 2. 30 degrees over here. If this is 30, what's the actual angle?
180. 180.
Almost. How many degrees would this be?
Oh, it's 100. So minus it's 120.
Try again. Try again.
Goddamn, it's 150.
Careful, this is the Oval Office, but I'm glad you're so invested.
150.
150. That's right. This is 150 degrees. Any questions about the 150? Any questions about that? Okay, at 150 degrees, we're going to get cosine and sine. Now, do you agree that it's the exact same as these? The exception of maybe one or both negative? What's negative here, x or y? X. So what should we write in this case?
Negative. Yeah.
Say it.
Yeah. Root 3/2.
And y is still
Y is still positive.
1/2. So the cosine of 150 is, I gotta put this down, very important.
Got it.
The cosine of the angle 150 is?
150.
It's negative
Good.
root 3 over 2.
And the sine of 150 is?
1/2.
Good, good. Let's do 30 degrees in quadrant 3.
Oh no.
So we can extend this line.
That's just a
How many degrees is this?
180.
Plus
30.
makes
210.
210. Good job.
10.
What is the cosine of 210?
Negative rad 3 over 2.
That's true.
Then
Comma
also
negative
include-
1/2.
Yep.
Good.
Yep.
Very nice. 210. Negative rad 3 over 2, negative 1/2. Let's do 30 degrees in quadrant 4. Extend this line.
Positive rad 3.
Yeah. Positive rad 3 and negative 1 over 2.
Good, good. What's the angle? Very nice.
We are so good at
What's the
So
angle?
fire.
How many degrees?
What?
Rad 3 over. Wait,
That's the ratio. What's the angle? What is this angle? We're talking about
240.
all the way around.
240.
Oh,
240.
It's not 240, good
270.
guess.
No.
300.
Oh, wait. 330.
330.
Yes.
330. This is a great way to end. 330. And now you already gave the ratio. What is the cosine of 330?
2 pi. No, that's something
All these,
completely
it's these.
different.
Cosine is negative. Wait. Yeah. Wait.
Oh, it's
Negative.
positive. It's positive,
It's
right?
positive
X is
rad
positive.
3 over negative 1 over 2.
All right. Positive rad 3 over 2. Negative y. The y goes down. All right, great job. Great job. Now let's do 60 degrees. Let's do 60 degrees. Okay, so imagine we had, let's do that in green. We're going to do like a 60-degree triangle over here. And then we'll replicate it all the way around. All right? Where's the 1 across from?
Oh, isn't
No, where's the 1 across from?
the 30.
The 30, where's the root 3?
60.
And 2?
Hypotenuse.
Very good. What is the cosine of 60? No, you look at it here.
1/2.
1/2 because it's adjacent over hypotenuse. Good job. It's adjacent over hypotenuse is 1/2.
Yeah.
And what's the sine of 60?
3 over root 3 over 2.
Root 3 over 2.
So it's the same thing.
Oh, yeah. Wow.
Do you see how it's inverted like
Yeah,
that?
so it's the
Yeah.
exact same thing, just different angles.
Yeah, and you're
Exact
flipping
same
these
thing,
two.
just a little different.
That's actually an expression in Thai. When I visited Thailand, that's part of their culture. Same, but different. Everything in life is same, but different. Would you agree?
Presidential candidate.
Yeah. We should use that on the campaign trail. Oh, never mind. I already won both.
The term exactly the same, if you think about it, doesn't make sense at all. Because
I-
something
yeah.
the same means exactly alike. So something
Right.
is either the same period or not at all.
I get it. I totally get it. But, in a sense, you can maybe get behind
Exactly, it's just
I
emphasis
hate
there.
the saying, I know everything except for this one thing. Because obviously you don't know
it.
everything.
Right.
Obviously you don't know everything.
All right, let's do 60 degrees. 60 degrees. What is the cosine of 60 degrees?
1 over 2.
1 over 2. It's a
Whoa.
game show. What is sine of 60?
Rad
3 over 2.
That's 3 over 2. What do we win?
We're going insane!
We're going to Disneyland.
Now we have 60 degrees in quadrant 2.
Which is.
Folks, tell them. How many degrees is that? Yeah.
What?
60 degrees in quadrant 2
It-
is 60 away from 180.
Yes.
It's
No, it's
1.
closer.
It's 120.
Good. 120. Very nice. 120. All right. What is the cosine of 120?
Negative 3
1/2.
rad. What? Oh, wait. Over.
X is XY. Negative.
1/2.
X is negative. What's Y?
Rad 3 over 2.
Positive rad 3 over 2. Excellent. Let's go to quadrant 3. Extend the
What's
line.
in quadrant 3?
What is in quadrant 3? All right, hook it up. So this is 60 more than 180 makes
Negative rad 3 over 2.
No, we want the angle first.
Oh, so sorry.
The reference angle is 60 away.
240.
240. Good job. 240. What is the cosine of 240?
Negative 3. Negative rad 3 over 2. Oh,
Sine?
Negative 1/2.
All right, and finally, 60 degrees reference in quadrant 4.
300.
Say it.
Yeah, just.
What is your profession? You get another reference?
300.
Oh! Spartans! All right, so this is 300. Hook it up. What is the cosine of 300?
3 rad 3 over 2.
Yeah, no.
No, 1 over 2.
Yeah,
And negative.
positive x.
Yeah, and then negative root 3 over 2.
Excellent, excellent. Okay, one more to do. We're going to do the 45, 45, 90s, okay?
Oh.
We're going to do 45, 45, 90s, then
I
we're done.
never liked those. 45,
We're going to do one more.
I like the 30, 60, 90.
That was
I do
quite
not
the
like
exhale.
Yeah, like, oh.
40.
I do appreciate the honesty, I got to say.
Why'd you erase every toe again?
Because you don't need it.
Oh my god!
Everything that happens.
We are losing it.
If only you were the
Off the hinges, yeah. This is what I wanted to do as president.
It's not time of the day.
Yeah. All right, hook it up. This is 45.
Of the night.
Sides. Legs are.
45, 45.
Legs are.
Oh,
One.
1.
One. Hypotenuse.
Rad 2.
What is the cosine of 45?
Wait.
Opposite over hypotenuse.
That's
1 over
sine.
rad 2.
Adjacent
2
over
rad over
hypotenuse.
2.
Which is 1 over rad 2, which simplifies to root 2 over 2. That's right. That's right. And what about the sine of 45? Opposite
is
over
the
hypotenuse,
same thing.
which is 1 over rad 2, which is root 2 over 2. Okay.
Oh, nice.
So they're the same, right? So let's go ahead and slide in. So this is 30, this is 60. We're gonna slide in, we'll put it in dots so we can see it a little better. This is 45 degrees. In the unit circle with hypotenuse 1, what's the cosine of 45?
Dead.
Sine of 45. Go ahead.
Rad 3 over 2. No, rad
No,
1
1 over. Wait, no, 2
1
rad.
over rad 2. Rad 2 over 2.
Rad 2 over 2.
Rad over rad 2 times.
Dragon
Oh my
said-
God.
And then it's negative rad
Yeah,
2 over
first give me the angle.
2.
First give me the angle.
The angle is going to be.
Good job.
Stop. Nope. 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 Is it? I just lost.
You got
Just a
it.
bunch of grunts and struggles.
You will. You will.
No, I keep doing +4. 225.
That's over here.
Okay.
It's 45 away from 180 less.
It's minus 180.
Yeah.
Or 180 minus.
So it's 135.
Good.
125.
All right, hook it up. Cosine, sine. Cosine of 135. Sine of 135.
Cosine is negative root 2 over 2.
Sine.
2 over
Root
rad
2 over
2.
2.
Very good. All right, now we have this one between.
And then it's 225.
220.
I got it. Shut up. Yeah, it's 225.
And then it's negative.
Yeah, it's negative.
There you go. Now you're finding the pattern. I'm so happy.
Yeah.
We're getting so lazy.
No, I know what you mean though. That's the whole point.
And then it's
It's gonna shoot.
295.
And it's gonna shoot.
Good guess.
Got
It's
it.
not.
Oh
It's
no.
315.
315.
How'd you?
45 away from
Yeah.
360. All right, positive, negative. What is it? Negative, positive. What do you got?
It's positive, negative.
Yes, root 2 over 2.
Can I take a picture of that?
We're almost done with it.
I know.
We're almost done with it. We're not done. We're not done.
No, I know. I meant like once we're done.
Yeah, once we're done, sure. Last piece.
Oh my lord.
Do you agree? I know I said this was the last. There's one more. It's more easy. Do you agree that all these hypotenuses are 1? Do you
Yes.
agree? The hypotenuse is always 1 on the unit circle. That's 1 unit. Hypotenuse is always 1, creating these rules. Cosine of the angle, sine of the angle. So don't forget about these. If the hypotenuse is 1, what is this point? Very simply. This length is 1.
That's 1.
Comma.
Then it's comma 2 rad over 2.
This is the y value. What's the y value here?
Oh yeah, 0.
Good.
Oh lord.
Good, good. And I'll just throw this in. You don't have to retain it right now. This is cosine of 0, sine of 0. Cosine of 0 is 1, sine of 0 is 0. Let's do this point. at a length of 1, what is the value? What, comma, what? X is,
90.
1.
At.
oh, you're close. You
Oh,
have it
no,
right here.
it's 0.
0, comma, good. This is the cosine of what angle?
1. Of
90.
90.
I
Oh
know.
Lord.
Sine of 90.
Okay.
Okay, you're getting the hang of it.
Okay.
What is this point?
This point?
One,
no, I'm on the.
You do it, yeah, do it.
Okay. The sign is
First-
it's
first
gonna
the point.
be -1.
-1,
0.
very good. And what is the angle? Good
The
job.
angle is 180. Okay,
That's
I
the
got this
cosine
now.
of 180. Sine of 180.
You are in the zone.
You're crushing
I am
it.
in the zone.
All right, one more. This is seriously the last one. What is the point?
The points, negative. Wait. No, 0, -1.
How many degrees?
270.
Cosine of 270. Sine of 270.
I've never. Okay, this is great.
Ladies and gentlemen,
Let me look. Well,
That's.
You get a medal of honor.
oh my
The
God.
fact that I understand everything
This is
that's on
crazy.
that.
All right, yeah, take a
Ladies
picture of
and
that.
gentlemen,
Wait. Go next to it, yeah.
Wait, so what did we just learn? I'm just kidding.
No, you're covering the sign.
Oh, yes, sir.
ladies and gentlemen,
Good.
Wait, yeah.
this has been
And that's not like the president.
Oh, hello. Yes, sir.
Thank you. This is perfect.
Or how about a look of fear?
Wait,
wait.
do the other one. Do the other one.
No,
Wait.
wait, just look scared at wait, look scared at the board.
Okay.
You got it.
All right, you guys,
Ladies
give
and
yourselves
gentlemen.
a massive hand. Give yourselves a hand. That was great. Thank you. We are done.
this has been
All right.
ObaMATH.
Yeah, this has been ObaMATH. Check us out on what website?
Yaymath.org.
You freak out. Bye.
Oh my
Hello, I'm President Barack Obama. In any approaching election season, it is of the utmost importance to vote. Your vote directly shapes the future of our nation. Simply Google how to register to vote for details in your area. I'm Barack Obama, and I approve this message.